The United States government built a nuclear waste containment structure with no bottom. That sentence is not a metaphor. It is an engineering specification. The Runit Dome, 460 feet in diameter, constructed from 358 concrete panels, each 18 inches thick, sitting on the northern tip of Runit Island in the Marshall Islands, has no liner, no membrane, no barrier of any kind between 111,000 cubic yards of radioactive fill material and the porous coral substrate beneath it. The Pacific Ocean moves through that substrate twice every 24 hours, driven by tidal pressure. It enters the unlined crater floor, circulates through the plutonium-bearing fill, and drains back out into the lagoon. The dome does not contain the radiological inventory. It conceals the dispersal mechanism from aerial observation. These are not the same function. The federal record has consistently described them as though they are. What follows is the audit of that record. Enuitak Atoll is a coral ring of approximately 40 islands arranged around a central lagoon in the western Pacific, roughly 2,400 miles southwest of Hawaii. The maximum elevation of any island in the chain is approximately 6 feet above mean sea level. The substrate beneath every island is calcium carbonate, biologically constructed, porous, and freely permeable to groundwater. The resident Marshallese population in 1947 numbered approximately 145 individuals. The United States military designated Enuitak as a nuclear weapons testing range in that year. The residents were relocated to Ulang Atoll, 200 miles to the southwest, on the stated condition that the relocation was temporary. The relocation lasted 33 years. The testing began the following year. Between 1948 and 1958, the United States detonated 43 nuclear devices at Enuitak Atoll. The devices ranged in yield from sub-kiloton fission devices to thermonuclear weapons in the megaton class. 11 of the 43 detonations were surface bursts, or near-surface bursts, configurations in which the fireball makes direct contact with the coral substrate, vaporizing it, irradiating it, and redistributing it as radioactive particulate fallout across the surrounding islands and lagoon. Several smaller islands in the atoll chain were physically removed from the geography of the Earth. Their mass was converted to fallout. The isotopic inventory deposited across the atoll during this period includes cesium-137, strontium-90, americium-241, and plutonium-239. Plutonium-239 is an alpha-emitting transuranic element with a half-life of 24,100 years. It does not decay on any timescale relevant to human institutional planning. It accumulates in biological tissue following inhalation or ingestion, and delivers continuous alpha radiation to surrounding cells from the interior outward. The atoll received it in weapons-grade concentrations, deposited by surface detonations across multiple islands and directly into the lagoon sediments across a 10-year period. The detonation with the most direct structural consequence for this analysis occurred on May 5, 1958. The device, designated Cactus, was part of Operation Hardtack 1. It was a fission weapon with a yield of 18 kilotons, detonated at ground level on the northern end of Runit Island. The blast excavated a crater 30 feet deep and 350 feet in diameter into the coral substrate. The explosion scattered weapons-grade plutonium contamination across the surrounding island surface and into the adjacent lagoon. The crater remained open and exposed to the environment for the following 20 years. Tidal groundwater cycled through the coral beneath it twice daily. Rain fell into it. Wind moved contaminated particulate matter off its surface. What? No remediation action was taken during this period. The crater functioned as an open radiological source in direct tidal communication with the surrounding ocean for 2 decades before anyone was assigned to address it. The political context that eventually produced the cleanup operation was not primarily radiological. By the mid-1970s, the United States was in active negotiation with Marshallese representatives over the terms of the Compact of Free Association, an agreement that would formalize the end of the Trust Territory Arrangement and establish a new framework for the U.S.-Marshallese relationship, one that the United States had material interest in concluding favorably. The Marshallese had been requesting repatriation to Enuitak for years. A remediation program for the atoll became a component of the broader political negotiation. The Inuitak Radiological Support Project was funded and initiated. Its operational parameters were set within budget and schedule constraints determined by the broader political timeline, not by radiological engineering standards. 4,000 United States military servicemen were deployed to Enuitak Atoll between 1977 and 1980 to conduct the cleanup. The operational scope was the physical collection and consolidation of contaminated material from across the atoll's islands. Workers scraped topsoil from contaminated island surfaces using bulldozers, scrapers, shovels, and rakes. They collected contaminated coral substrate, contaminated vegetation, and contaminated military hardware. All of this material was transported to Runit Island and consolidated. The personal protective equipment issued to these workers is a matter of documented record and subsequent litigation. Standard military work gear was the baseline. Respiratory protection was inconsistently issued and inconsistently worn. Dosimetry issued to the workers was calibrated primarily to gamma radiation, a penetrating radiation measurable at distance using film batch technology standard to the period. Plutonium-239 is an alpha emitter. Alpha radiation does not penetrate skin. It is not the external exposure pathway that creates the primary biological hazard. The hazard pathway for plutonium is inhalation of fine particulate matter, which deposits plutonium in lung tissue and continues delivering alpha radiation to surrounding cells for the remaining life of the exposed individual. The dosimetry systems in use during the Enuitak cleanup were not designed to capture the primary exposure pathway for the primary hazard isotope. The exposure records generated by those systems are therefore not an accurate account of what the workers actually received. Many of these veterans have since developed conditions consistent with radiological exposure and have encountered sustained difficulty obtaining federal medical benefits. In part because the official exposure record, the record that does not accurately measure what it purports to measure, does not support their claim. The collected material totaled 111,000 cubic yards. This figure is the official volumetric record of the radiological inventory moved to Runit Island. It was mixed with Portland cement on site to create a stabilized fill, a standard immobilization technique intended to reduce the mobility of radioactive isotopes within the consolidated mass by binding them in a cement matrix. The stabilized fill was deposited directly into the Cactus crater. No liner was installed. No geomembrane, no clay barrier, no concrete floor panel, no impermeable layer of any kind was placed between the radioactive fill and the crater floor. The fill rested on open coral substrate. The engineering documentation from this period does not contain a hydrological assessment of tidal groundwater behavior at the Runit Island site. The permeability of the coral substrate and the behavior of tidal groundwater in atoll environments were not incorporated into the containment design as constraining parameters. The crater was treated as a natural receptacle rather than an engineered cell with a defined containment function. The decision to omit the liner may reflect a cost and schedule judgment, a genuine failure to account for the site's hydrogeological characteristics, or both. The available record does not resolve this question. What it does establish is the outcome: a radiological fill deposited without a liner on permeable substrate in an active tidal environment, and then capped with a concrete dome and administratively designated as contained. The cap itself was a substantial construction effort. 358 concrete panels were manufactured on site and placed over the filled crater to form a dome structure 460 feet in diameter and approximately 25 feet high at the apex. Each panel was 18 inches thick. The concrete was mixed using locally available coral aggregate, calcium carbonate material, rather than the silicate aggregate used in standard construction-grade concrete. The joints between panels were sealed with a bituminous compound. A single inspection hatch was installed at the dome's apex. A low perimeter retaining wall was constructed around the base. The structure was declared operationally complete in 1979. Internal documentation from this period characterizes the dome as a temporary facility with an expected operational life of 25 to 30 years, pending the identification and implementation of a permanent disposal solution. No permanent disposal solution was subsequently identified or implemented. No alternative facility was constructed. No upgrade program for the dome was initiated when it reached the end of its design life. The structure transitioned from temporary to permanent through the accumulation of institutional inertia and the progressive political cost of reopening a ledger that had been administratively closed. The hydrogeological mechanism by which the dome disperses its inventory rather than containing it follows directly from the physical properties of coral atoll geology, properties that were well documented in the scientific literature at the time of the dome's construction. Coral is a calcium carbonate biological structure. It is not bedrock. It is not an impermeable geological formation. Its fundamental physical characteristic is porosity. It is riddled with interconnected channels, voids, and fractures that allow water to move through it freely under pressure. The permeability of Runit Island substrate is high. Seawater and groundwater interact continuously through the coral matrix. The tidal cycle is the operative mechanism. When ocean tide is high, the hydraulic head of the surrounding seawater exceeds the hydraulic head of the groundwater within the island's substrate. This pressure differential drives seawater laterally and upward through the permeable coral. Groundwater levels within the island rise with the ocean. When the tide falls, the differential reverses. Groundwater drops, draining outward through the coral and discharging into the surrounding water body. This cycle repeats twice per 24-hour period without interruption. In the context of the unlined Runit crater, the tidal flushing cycle means the following. At high tide, seawater enters the unlined crater floor from below, rises into contact with the radioactive fill material, and circulates through it. At low tide, the water drains back down through the crater floor and outward through the coral substrate into the lagoon. What leaves with the water is a function of what the water can mobilize from the fill: dissolved ionic species, fine particulate matter in colloidal suspension, and isotopes associated with either phase. Cesium-137 and strontium-90 are relatively soluble in groundwater and mobilize readily under tidal flushing. Plutonium-239, while poorly soluble in ionic form, associates preferentially with fine particles and colloidal material that remain in suspension in moving groundwater. The transport of colloidal plutonium through porous carbonate media is not well retarded by the geochemistry of calcium carbonate substrate. Coral does not provide the sorption capacity that iron oxide-bearing clays in continental soil environments provide. The mobility of plutonium through the specific lithology beneath Runit Island is materially higher than would be predicted from models calibrated to standard soil environments. The dome was built on the substrate least suited geochemically to attenuate its primary isotopic hazard. The result is a dispersal function that operates continuously on tidal schedule, without mechanical failure or human negligence as a prerequisite. The dome does not need to crack for this process to occur. The dome does not need to be breached by a typhoon. The flushing mechanism is the baseline operating condition of the structure as built, a direct consequence of the decision not to line the crater floor. It has been the baseline operating condition since the day the dome was sealed in 1979, when monitoring programs confirmed the presence of plutonium isotopes in groundwater, sampling wells adjacent to the dome and in lagoon sediment samples in the 1980s and 1980s. The Department of Energy and associated federal agencies were required to produce a formal response to the documented dispersal. The response they produced is the administrative artifact that defines the federal position on the Runit Dome to this day. The argument is structurally precise. The Enowatak Lagoon received direct radiological deposition from 43 nuclear detonations between 1948 and 1958. The lagoon's sediments contain plutonium, cesium, americium, and strontium at concentrations elevated above natural background levels as a result of that test program. These concentrations constitute the environmental baseline for the Enowatak Lagoon. When the daily plutonium flux from the dome's tidal flushing is expressed as a proportion of the total radiological inventory already present in the lagoon from the original test program, the marginal contribution of the dome leakage is statistically small. The official position therefore characterizes the dome's leakage as not meaningfully worsening an environment whose radiological condition was established by the original federal test program. The logical architecture of this position rewards precise examination. The federal government is invoking the radiological contamination it introduced through 43 nuclear detonations as the reference baseline against which the performance of its own cleanup program is measured. The severity of the original contamination event functions as the defense for the inadequacy of the remediation. The argument does not dispute the leakage. It disputes the relevance of the leakage. I was calc. It does not claim the dome is working. It claims the dome's failure is statistically marginal against a background that the federal government itself created. This is not an engineering defense. It is a statistical reframing of ongoing dispersal as negligible degradation of a pre-degraded system. The pre-degradation and the ongoing dispersal share the same federal origin. The same institutional actor that contaminated the lagoon through testing is now citing that contamination as the standard against which its cleanup is assessed. The circularity of this defense is the most precise statement available about the actual institutional commitment to remediation outcomes in this region. The Marshall Islands government, the Marshallese people living in the vicinity of this ongoing dispersal event, and the international scientific community assessing the dome's condition have not uniformly accepted this framing. The Nuclear Claims Tribunal, established under the Compact of Free Association to adjudicate Marshallese claims for radiological damages, awarded approximately $2 billion in damages across claim categories covering nuclear testing harm. The United States Congress appropriated approximately $150 million of that amount. The ratio of adjudicated award to actual appropriation is a fiscal statement of institutional follow-through on the commitments embedded in the remediation narrative. The dome's structural condition is not static. The physical processes acting on it are progressive and cumulative, and they have been operating for over 45 years on a structure designed for a 25 to 30-year operational horizon. The concrete panels are degrading through several concurrent mechanisms. Daily thermal cycling under equatorial solar radiation, the expansion and contraction of concrete as surface temperatures rise and fall through each 24-hour period, propagates microcracking through the panel material over multi-decade timescales. The coral aggregate used in the concrete mix has thermal and mechanical properties that differ from standard silicate aggregate, and the calcium carbonate chemistry of that aggregate makes the concrete matrix more susceptible to dissolution by acidic chemical species generated internally during the carbonation process. The marine chloride environment penetrates the concrete matrix and reaches embedded steel reinforcement, initiating corrosion processes that generate oxidation products with greater volume than the original steel, producing internal tensile stress that propagates additional cracking and eventual surface spalling. The bituminous joint sealant applied in 1979 between the dome's 358 panels has a finite service life under combined exposure to ultraviolet radiation, thermal cycling, and salt spray. After 45 years of all three, the joint seals are not performing at original specification. Inspection documentation produced by Lawrence Livermore National Laboratory and Department of Energy contractors over the past several decades records progressive joint, panel cracking, and surface spalling. These findings are not in dispute in the technical literature. The dome's structural condition is consistent with a marine concrete structure that has exceeded its design service life without adequate maintenance intervention. Typhoon overwash events compounded the degradation rate on a non-linear timeline. The Western Pacific Typhoon Belt traverses the Marshall Islands region regularly. Severe tropical cyclones generate storm surge that overtops the low-lying topography of atoll islands, depositing seawater across the dome surface, and through existing joint openings and panel cracks, into the dome interior. Each overwash event introduces additional chloride loading into the concrete matrix, accelerates internal corrosion, and mechanically erodes the surface through wave action. The cumulative effect of repeated overwash events on a concrete structure with existing microcracking is acceleration of the degradation trajectory rather than discrete damage events. Sea level rise is the parameter that makes all other degradation factors irreversible on any practical planning horizon. The Pacific Ocean has been rising measurably for decades. The rate of rise is increasing. For a coral atoll whose maximum elevation is approximately 6 feet above mean sea level rise does not need to reach catastrophic magnitudes to fundamentally alter the risk profile of structures and populations on the islands. As mean sea level rises, The tidal groundwater table beneath Runit Island rises with it. The hydraulic head, differential that drives the tidal flushing of the dome's unlined base, is operating against a baseline water level that has shifted upward from the conditions that existed when the dome was constructed. The frequency and magnitude of tidal contact between the Pacific Ocean and the radioactive fill inside the dome is increasing over time. The tidal flushing dispersal mechanism is not static. It is intensifying. Rising mean sea level also lowers the effective threshold for typhoon storm surge to overtop the dome perimeter and the surrounding island surface. Events that were historically contained within acceptable parameters now exceed them more frequently. The erosive and chemical damage accumulating from each such event is compounding. The Marshall Islands government has formally submitted to the United Nations that the long-term physical survival of the nation's territory under projected sea level rise scenarios constitutes an existential challenge to national continuity. Under intermediate and high emission scenarios developed by the Intergovernmental Panel on Climate Change, low-lying portions of the Marshall Islands land area face near continuous inundation risk by the end of the current century. The dome does not need to be actively destroyed for this trajectory to render it a direct ocean floor deposit. If the island substrate surrounding and supporting the dome is inundated and eventually eroded by sustained ocean exposure, the dome transitions from an above-grade cover structure to a subsurface feature of the ocean bottom, with no remaining separation between its contents and the surrounding seawater beyond whatever structural integrity remains in the degraded concrete pan. This is the terminal condition of the ledger as currently structured. Plutonium-239 decays on a half-life of 24,100 years. After one half-life, half the original inventory is gone. The other half remains. After two half-lives, 48,200 years, 1/4 of the original inventory is still present. The material inside the Runit Dome will remain biologically hazardous on any reasonable toxicological standard for timescales that exceed the entire recorded history of human civilization by factors of 2, 3, and 4. The dome, designed to last 30 years, now past 45, degrading on a documented progressive trajectory, sitting on a sinking island in a rising ocean, is the only engineered barrier between that inventory and the Pacific Ocean. It is a barrier with no bottom, through which the ocean has been cycling twice daily since 1979. The institutional frameworks constructed to monitor, maintain, and politically manage the structure, the Department of Energy oversight programs, the Compact of Free Association mechanisms, the Nuclear Claims Tribunal, the bilateral diplomatic channels will not persist for 24,100 years. No human institution ever has. The oldest continuously operating institutions in human history are measured in centuries. The oldest nation-states are measured in hundreds of years. The plutonium does not operate on an institutional timeline. It operates on a nuclear physics timeline. The tidal cycle does not recognize the expiration of federal oversight mandates. The coral substrate does not acknowledge the conclusion of remediation programs or the closure of administrative ledgers. The ocean is indifferent to the distinction between contained and covered. 4,000 servicemen scraped the islands of Eniwetak with shovels and loaded the results onto barges. They mixed it with cement and dumped it into a crater and put a concrete lid on top. They were told they were solving the problem. Some of them are still trying to get the federal government to acknowledge what happened to their lungs. The Marshallese were told they could come home to a remediated atoll. Some of them still cannot return to their home islands because the radiological inventory was not fully removed. It was consolidated. The dome is the consolidation. The dome leaks. The federal record describes a cleanup. The tidal record describes a dispersal mechanism operating on a twice-daily schedule for 45 years and counting. Both records are accurate. They are describing different things. The audit continues. There is a secondary ledger that the official federal account does not fully address, and it concerns the 4,000 men who performed the labor. The Enuitak cleanup veterans, organized in part through the National Association of Atomic Veterans, have documented a pattern of health outcomes that the existing exposure record does not adequately explain or account for. Elevated rates of certain cancers, respiratory conditions consistent with chronic inhalation of fine particulate matter. These outcomes are not scientifically surprising given the nature of the work performed. Workers scraping plutonium-contaminated soil in open air, in equatorial heat that reduces compliance with respiratory protection, handling contaminated material without positive pressure protective equipment, in some documented cases eating meals in the field without decontamination protocols. The inhalation exposure pathway was present, repeated, and sustained across a 3-year operation. The dosimetry record that the federal government holds for these workers is a gamma dosimetry record. Film badges and pocket dosimeters calibrated to penetrating radiation. Gamma radiation from isotopes like cesium-137 was detectable by these instruments. Alpha radiation from plutonium-239 is not detectable externally. An individual worker could have inhaled a quantity of plutonium-239 sufficient to produce long-term lung irradiation, with biological consequences decades later, and that worker's official exposure badge would have recorded 0 dose from the plutonium, because the badge was not measuring the pathway by which plutonium is dangerous. The official exposure record is therefore not a record of what workers were exposed to. It is a record of what one type of radiation detector, calibrated to one radiation type, measured in one exposure geometry. It is a partial record presented as a complete one. When a veteran of the Enuitak cleanup presents with lung pathology and a radiogenic mechanism is biologically plausible, the federal response has frequently been to invoke the official dosimetry record, the record that cannot measure what it would need to measure to be relevant, as evidence that the exposure was insufficient to produce the reported outcome. This is a circular argument built on an instrumentation limitation that the federal government imposed on the measurement system. The parallel to the dome's administrative management is structural. In both cases, the dome's leakage and the worker's exposure, there is a measurement system, an official record produced by that measurement system, and a defense built on that record. In both cases, the measurement system was not designed to capture the primary mechanism of concern. The dome's monitoring, until independent scientific assessments forced a broader accounting, was insufficient to characterize the tidal flushing pathway. The worker's dosimetry was insufficient to characterize the alpha inhalation pathway. The official records from both systems are accurate within their own parameters and inadequate as complete accounts of what actually occurred. The Marshallese experience of the dome runs through a different institutional channel, one that has produced its own documentary record of official inadequacy. The Nuclear Claims Tribunal was established under Title I of the Compact of Free Association, enacted by the United States Congress in 1986. The tribunal was funded with $150 million authorized to hear claims for personal injury, property damage, and loss of use of land resulting from the United States nuclear testing program. It operated for approximately 2 decades before concluding its work. The tribunal's final awards, issued in 2001, totaled approximately $2 billion across all claim categories. The personal injury awards covered residents of Bikini, Eniwetak, Rongelap, and Utrecht atolls, addressing documented radiological health consequences across the Marshallese population. The property damage and loss of use awards addressed the decades during which Marshallese communities could not inhabit their home islands due to radiological contamination. The United States Congress had appropriated $150 million to fund the tribunal. The tribunal's awards exceeded that appropriation by a factor of more than 13. Congress did not supplement the appropriation to cover the awarded amounts. Individual claimants who had been adjudicated as entitled to compensation by the tribunal's legal process received cents on the dollar for their awards, or in some categories received nothing, because the fund was exhausted before their claims could be paid. The legal mechanism for Marshallese to seek additional compensation from the United States was the changed circumstances provision of the Compact of Free Association, which allows the Marshall Islands government to petition Congress for additional funding if the existing compensation framework proves inadequate. The Marshall Islands government submitted a changed circumstances petition. Congress has not acted on it in the years since. The petition represents the formal acknowledgement by both parties that the existing compensation framework is inadequate. The inaction on the petition represents the federal government's operational response to that acknowledgement. The physical baseline of the dome exists within this institutional context. The structure was built as part of a remediation program driven by political timeline constraints. Its adequacy was certified by the same institutional actors who conducted it. The monitoring of its performance was designed and funded by the same federal agencies, with budgetary interest in the cleanup being characterized as complete. The defense of its leakage was constructed using the contamination produced by the same federal program. The cleanup was intended to address the compensation mechanism for those harmed by both the testing and the inadequate cleanup was funded at a level that covered approximately 7 cents of every dollar adjudicated as owed. This is the complete administrative architecture of the Runit Dome. The engineering omission, the unlined crater floor, is not an isolated technical decision. It is the load-bearing element of a structure that is simultaneously physical and institutional. The physical structure is a concrete dome on a sinking coral island. The institutional structure is a framework of records, appropriations, legal mechanisms, and official positions that together produce the outcome of ongoing dispersal, managed as an administrative condition, rather than addressed as an engineering failure. The tides do not read the administrative record. The calcium carbonate substrate of Runit Island does not recognize the difference between a classified remediation program and an unclassified one. The plutonium-239 inside the dome does not decay faster because the Nuclear Claims Tribunal found the Marshallese entitled to $2 billion. The concrete panels do not stop cracking because Congress declined to appropriate the funds the tribunal awarded. The dome is 460 feet in diameter. It has no bottom. The Pacific Ocean enters it twice a day. It has been doing this for 45 years. The audit is not closed. It was never closed. The federal record closed it. Those are different things.